On page 40, let's remind ourselves what the heck we did on block day when we did all that stuff. So let's go ahead and move our stuff to page 40. Here we go. This is what we did on Tuesday. It says, here's this beautiful region R. Vivian.
Yeah.
Hey, we've got this region without a calculator. It says we've got the graph of root cosine and e to the x. Region R is the base of a solid. Oh, we've got my beautiful demonstrations. We got base of a solid. And it says whose cross sections perpendicular to the x-axis. So would you agree perpendicular x-axis looks like that? And so the little cross sections would just be in region R from there to there. And it says it's a semicircle. Okay, how cute. It's going to be like this, woo. And then I got another semicircle, woo. And then I got another semicircle, woo. All these semicircles. Ooh, I would like someone to make me one of these in Ginnert's room when we do this in May with semicircles. That'd be sweet. Yeah. I need that. Everest, roger that. You on it? Thank you. So we're going to have all these semicircles sticking out. It says we've got semicircles. The diameters are on that XY plane. Great. We love these, don't we? Vivian.
My apologies.
Right, but do not evaluate an integral. That gives the volume of this solid. You guys, just a reminder from what we did on block day is we're going to integrate the area of the cross section. That's how you find the volume. Area of a cross section. What are this cross section shapes going to be here? Semicircles. How about I find the area of a semicircle?
1/2 pi r squared.
1/2 pi r squared. And when I integrate that, I will get the volume of this cute little thing. Okay. You guys, we got to go find that radius. I'm going to erase. Help us see. I'm going to just draw one of these in to maybe help us draw. Whoop, I'm going to go back to my pink. Okay, maybe not. Salmon. You guys, how am I going to find my radius? Whichever one is the top. I agree. Which one of these is going to be root cosine versus the square root of root cosine versus e to the x? E to the x is the pink one. Agrees. The top one. I like how people said that. That's the top one. Root cosine of x is the bottom one because my girl Maddie said yesterday, what do we always do in here? Upper minus lower. Top minus bottom. Whatever we want to do. Because wouldn't cosine, if I did cosine, that gives me this blue distance. That's that blue distance. And then, I'm sorry, e to the x is my blue distance. Root cosine x is that green distance. And if I subtract them, I'd be left with this pink distance. So we're going to do upper minus lower. Is that 1/2 pi r squared? Love it. What about my balance?
0 to 1.5.
0 to, I feel like I left something off of this.
Yeah, it looks like it's a little...
Hilarious. I think it's supposed to be pi over 2. My bad. I cut that off of the problem. This needs to be vertical line is pi over 2. It should have said from 0 to pi over 2. My bad.
Can we take the 1/2 pi, the outside?
1/2 pi is a constant. You could totally leave it out there. E to the, and we don't have to solve it, but I agree. Just leave it out there. It could make your life a little easier. If you forget your dx on the AP test, they don't care. Cool, you guys? So this formula still applies to find the volume of anything. When we rotate this, we're going to look at this equation. Yeah. Here's where the food comes involved. People, I need us to try to draw what we just saw. For example, I want to take this image and rotate it about the x-axis. Here come our art skills. You ready? Determine the volume. Well, let's just first say we know volume is always the integral of the area of the cross section. Let's go try to draw what this will look like when I rotate it about the x-axis. Check this out. If I were you, I would go ahead and reflect it over. So you kind of see the reflection shape, and I did a terrible job on this side, so I'm going to try that again. I'm going to reflect that. Still, again, didn't do a great job. And then I'm going to rotate it. And I'm going to try to do a great job of showing, to me, this one. Well, you guys have to start guessing. What do you think this looks like? It does look like a football. Ooh, a chocolate colored.
Cadbury egg.
You guys, you hit the nail on the head. Now, I got to be honest. I couldn't find the dang Cadbury eggs. So I'm going to tell you what I got instead. And I think you're going to be gone with it. They're not. Let's go find the volume of that gum that you just put in your mouth. The volume, again, is always just the area of that cross section. You guys, what happens when I took that function and I revolved it about? What would this cross section shape be? Every single time. Actually, would it be a circle or an oval? It's just going to be a perfect circle because my drawing, I agree, didn't do it justice, but let's look at this. So just so you know, when I revolve this, that radius never changes. The cross section will always be a circle. Done. Why? Yesterday, we were talking about squares yesterday, because yesterday it was what the area of that shape where the cross sections, they told you that cross section shape on a flat surface can change. But at any time we're revolving about an axis, anytime I revolve about anything, oh, that's not going to work. It's going to be a circle, okay? So how do I find the area of a circle? Pi r squared. What is my radius here?
The function.
The function in this case is sine of x to the 1/2. To the 1/2. My bounds.
0 to 5.
Yes, ma'am. Without a calculator, we want to try this. Is this music to my ears?
Yes.
Yes. What is 1/2 to the second power going to do before I do any calculus? Cancel out. And I'm just left with pi from 0 to pi of sine to the first, or just sine, right? So to find the volume of that delicious egg candy. Let's do this by hand. Whose derivative is sine? Yeah, girl. I got my little pi just chilling. Then I got a negative cosine from where to where? 0 to pi. Upper minus lower, baby. Upper minus lower. So we got negative cosine of pi. Then what would we write? That's me plugging in my upper. Plus, because it'd be minus negative, plus cosine of 0. What is the cosine at pi? Here's the unit circle, half a pi, pi. Cosine of the x value is -1. So, yes, there's just going to be 1 plus 1, final answer, 2 pi, is the volume of this solid egg that you just ate. Rotate the region enclosed by, I know mine's got colors, so you guys tell me, which one do you think is x squared, green, red, or blue? Red. So you guys, if I were you on your page, I'd write this is x squared. Y equals 0. Here's y equals 0. And then x equals 2. It's right there. And they said, rotate that about the x-axis. I want to rotate this region about the x-axis. So you guys, oh, so you're saying if I were to reflect that, oh, snap. So you're saying if I rotated that about the x-axis, hold on, I feel like I didn't do a good job in my reflection. So I feel like I got to get a little closer. And again, your pictures do not need to be accurate, you guys. I just want to help you visualize it. So again, I'm going to rotate this cute little function of x squared around that x-axis. And when I do, what kind of solid do you think is going to be left? A Hershey Kiss. Now we got to go find the volume of this cute little Hershey Kiss on its side. Okay, you guys, when I rotated this around, and I'm going to show you another visual, You guys, what are the cross sections of your delicious Hershey Kiss? Circles, all day, every day. So to find the volume of anything, we're going to integrate the area of the cross section. That cross section again is a circle, pi r squared. If Ben Matter throws his pi in the integral, great, I don't care. We got to find my radius of this cute Hershey Kiss.
I see where you're going with the next one.
What do you think? X squared. She's saying just X squared. X squared, I'm going to put in bright green. Boom, that's X squared. Boom, that's X squared. For any X, what X's are we going to evaluate this from? Oops. 0 to 2. Those are my bounds. And what's my radius one more time? X squared. Thanks. Guys, we're going to do this one without a calculator too. Here we go. Volume is pi from 0 to 2 of x to the... Oh, first let's simplify it. Yeah, so if I just simplified it, now I'm ready to integrate it. You down with that? I'm going to leave my pi. X to the blank over blank. Beautiful. From 0 to 2. Upper minus lower. Anyone know what 2 to the 5th is? 32. Okay, people. 32 fifths minus 0. Can we just say 32 fifths pi? Great. Here's the deal. Here's this cute little x squared, negative x squared, shifted up 4. Here's the graph of 4 minus x squared. I'm changing it up on you. Look what I did. Find the volume of the solid by revolving it about the y-axis. We did that yesterday. As soon as you see y-axis, what are we putting as my dy? Agreed. Now, you guys, when we go revolve this about the y-axis and we revolve it, what are those cross sections going to be? Oh yeah, those cross sections are going to be circles. Good point. What's the solid that's going to be formed? In forms of the candy that I like. You know it's going to be a dot. Kind of looks like a bullet again. How do we find the volume of my dot?
You have to solve for x.
Ooh, I gave this as a y equals. And for this to be a dy, it needs to be an x equals, so all the y's are in the equation. How would I start getting x by itself here? I like adding x squared like you guys, some of you said. It just, to me, yeah, it saves some negative madness. How do I find x? X equals, yeah, why do I get to ignore the negative root? Exactly, it's in the first quadrant. All those are positive. Good, Mr. Merge. You guys, my function, this function right here, I'm going to put it in blue. This function is not only 4 minus x squared, it's also root 4 minus y. It's the exact same thing. But when I'm looking at it like this, I want you to think about it as root 4 minus y. You guys, is this green distance to the y-axis, please listen, root 4 minus y?
Yes.
Yeah, that's that. What is that symbolizing on my circle? The radius. Thanks, dude.
Is it still like the same formula?
Always. Yes, great question. So how do I find the area of that circle? Area of a circle. Pi r squared. What is my radius with respect to y? She said root 4 minus y. Would I want to simplify that before I integrate it? All day or day. The square root and the root will the square root and the square will cancel. Let's talk about those bounds.
0 to 2.
Careful on the y-axis. Yeah, don't we go, yeah. So much participation, I love it all. 0 to 4 on that y-axis. You okay with that? Aight, people, antiderivative of 4. 4y. Antiderivative of y.
Negative 1/2 of y squared.
Beautiful. Do all that from 0 to 4. My girl Maddie's just going to plug it in and not simplify, and I'm down with it. If we did simplify, whoosh, we're going to have a pi. I'm just keeping it outside. 4 times 4? 16 minus
0.
8.
Wait,
8. Wouldn't it be 8? 4 squared is 16 divided by 2? Then what are we subtracting? 0. Final answer. 8 pi. What I have is delicious. Here we go. Consider the region formed by 1/2 x to the minus 1. You down with that being here? Ooh, Kit Kat. I got you. It does have a little angle to it. I got you. It is not. Y equals 0. Y equals 2. And x equals 0. So many things. Jello. I love Jello, but no.
X equals 0.
Huh. You guys, they want us to revolve this about the y-axis again. Guys, I gave you a lot of room on your picture because this is a big revolution. Wouldn't it have to go like this?
Yes. Yeah, pretty much.
Right? I like Devin's affirmations. Isn't it going to be like this?
She bought us a giant Hershey cake.
So, wow.
Well, my revolution doesn't look quite as... Anyone have any idea in the forms of candy? Come on. Come on.
Rolo.
Okay, peeps. Let's go find the volume of that delicious Reese's cup. And I got to be honest, they look fresh. Like they're not dry on the inside, are they? Nice and... I'm not going to... Yeah, okay. Here we go. How do I find the volume of this Reese's cup where this... I meant to highlight this is a cross section.
Put it in terms of x.
He says if we're going around that y-axis, I got to put dy, and I need to put y equals, this is what it started as, 1/2 x minus 1. I need to make that an x equals. What are we doing first? Great, we're adding 1. Good job.
Yes.
Okay, then what are we going to do? Times 2, thank you. What are we going to end up with? 2y plus 2 equals x. This green line is the same as 2y plus 2. That blue line and the green line can be written in different ways, still mean the same thing. It's like me, Miss Lombardi and Mrs. Turner. Same person, just written differently. How am I going to find the volume of this cute circle? I'm sorry, the area of the circle. Pi r squared. What is my radius? Yes, 2y plus 2, pi r squared. You got it. Guys, let's just practice this on our calculator real fast. We got to do our bounds, though.
0, 2.
On the y-axis, you agree, went from 0 to 2. They gave us those bounds. They told us right there. How do we find the volume of anything? Yep. Well, actually, we're going to just say the area of the cross-section. We could say when something is revolved, if something is revolved around any axis, what is that cross-section every time? Yeah, if it's revolved, the cross-section is always a circle. I mean, I love me some double bubble, but that gets you literally 20 chews and you're done. Let's do this AP multiple choicer. I didn't give you a picture this time. Neither will AP on this one. Guys, what is the graph? It's that find the region enclosed by the x-axis. X-axis is blue. The line x is 3. Again, I think the bigger your pictures that you draw, the easier it is to visualize. The curve y equals root x. What does that look like? Boop. Just remember that it goes from the origin, boop, like that. Here's the deal. If you draw it inaccurately, it doesn't matter because as soon as they say rotated, you know that we're talking circles. If we rotate around anything, that cross-section is always going to be a circle. It's being rotated around that x-axis. Again, if you want to draw yourself this beautiful rotation, this is what mine would look like. Ugh, that's not very good. Let me try again. This is another ham, if you ask me, or a bullet, if you ask Elena. Guys, they want the volume of this solid. It's non-calc. We got this. How do I find the volume? It's just the area of the cross-section, and the cross-section is a circle. Area of a circle, pi r squared. What's my r here? Yeah, it's just my function.
So it's just x.
Yeah, root x squared will just leave me with x. Let's talk about those x bounds. 0 to 3. All right. See you at the end. Take that antiderivative, meet you there.
How are you supposed to?
Jack, do you ever have dreams of you like saying that in your sleep? Because I just feel like you say it so much.
I know I'm not Lewis in my head.
I don't know if that's true. If you just write the setup, that's 1 point. This, I believe, is 3 points. We'll go through. I do want to start how to break this down because this is non-calc. This looks brutal, doesn't it? Save yourself a step. Is 1/20th being squared? Yes. Is 1/20th squared a constant?
Yeah.
Could I take it out front? Yes, so I could put that with the pi. So you guys, again, I'm not expecting you to do this on your own, but we could say 1/20th squared pi, or you could say 1/400th pi. Either way, my integral is from 0 to 10. You guys, this 3 plus h squared is also being squared. We would need to distribute that out in order to integrate it. So this is the last thing. Can we square 3 plus h squared? Can you do that for me? What would that get me?
H to the fourth plus 6.
H squared.
Plus? Yeah, I would have gotten my 9 first, but again, I like that you guys put it in descending order. Then they said 6h squareds and an h to the 4th. We'll finish that tomorrow, but good start.